Okay, good morning, good afternoon, and good evening. Depending on when you're listening to this slide presentation, my name is Victor, and this is the Cisco CyberOps Training Net Academy curriculum. So this is the 26th module in the series. We're just about two modules away after this 26th module. So here we've looked at alerts, right? We looked at security data, and alerts is one of those security data. We've talked about log files, we talked about transactional data, session data. So how do we evaluate most of these alerts? It then means that we'll need one or two tools to be able to help us do that. One objective here is that we want to be able to explain, identify the structure of alerts, and explain how they can be classified. Sources of alerts. So where are we going to get our alerts? We're going to get our alerts from diverse sources. But how are we going to be able to monitor those alerts? How are we able to capture those packets of data? Security Onion is a very nice open source and also enterprise network security monitoring tool. Network security monitoring tool. You also have web monitoring tools, web system, WAFs, and like I mentioned, Sukuri. Sukuri does that excellently. Sukuri is spelled Sukuri. I think I'll need to get you their website. Their website is just a moment. Sukuri, uh, Sukuri. Just a moment. Sukuri.net. So their website is Sukuri.net. So they have a WAF. They have very very robust alert system that's implemented in a lot of applications. So, but if you're running on a net, if you're trying to run alerts, trying to check up alerts on a network, you can go for security onion. So this just tells you the range of tools. Normally, for a network security software, it's going to comprise several applications, several tools. They'll be able to use it to do help the SOC analyst to do inferences. So at the data layer, what are those guys that are going to help us collect data? So you have pcaps, host files, alert data, syslog data, metadata, session data, transactional data, content data. Then detection. What does detection when it pulls this data from all of these sources? So it's the CAPME, the SNOT, which is an IDS, the WAZO, the Sukurita, Suricata, then the OSEC. Then what does the analysis? What plots it in a graph-like kind of stuff? So Wireshark is able to segment this stuff for you. Kibana will be able to plot it in a kind of graphical manner. Squirrel we do a kind of a table similar to what you have as Wireshark. So each of the components works hand in hand, works together to ensure that we can monitor our uh, enterprise. So this is an explanation of each of those guys. From CAPME to SNOT to CISC to OSEC to WAZO to Sukurata. So the analysis tool, you have Squirrel, you have Kibana, you have Wireshark, you have Zik. So Kibana is very, very interactive dashboard. Uses Elasticsearch. So whatever you have, whatever data you collect, Kibana can do all of the plottings for you. I've had time to work with Kibana, use it to gather data, not just only from networks. Kibana can also be deployed for web applications. And of course, Wireshark. Wireshark is also part of the suite for security for capture, for full packet captures. So alert generation. So security alerts and notification messages that are generated by network security monitoring tools, systems, and security devices. Alerts can come in many forms depending on the source. In Security Onion, Squirrel provides a console that integrates alerts from multiple sources into a time-stamped queue. So each of them have time. A cybersecurity analyst walks through the security queue investigating, classifying, and escalating or retiring alerts. So if something is not within your work area or within your level of expertise, you might be a tier 1 or you might be a tier 2. The next thing you want to be doing is try to push that to the next person. Of course, if something is majorly informational, something is not going to have a real impact, or most of those impacts have been mitigated, or most of those vulnerabilities have been mitigated, you want to now retire those alerts. You just like want to archive them. So alerts will generally include five tuples information as well as timestamps and information identifying which device or system generated the alert. Of course, the source IP, the source port, the destination IP, the destination port, and of course the protocol number for the event. This is what it looks like. So you see this ST, the CNT, the count, the sensor. Um, this is what the SQL window looks like. Okay, if you're being asked, you should understand that you have NIDS, SNOT, ZIC, Suricata. So these guys, they operate at the network layer. It then means that if you want to use them to detect alerts, if you want to use them for network intrusion detection system, they can serve the purpose. But if we want to implement it just on individual or specific hosts, so a host-based intrusion detection system is going to suffice. So you can choose between OSEC and WASO and several others in the marketplace. Asset management and monitoring, passive asset detection system, PADS, HTTP, DNS, and TCP transactions are recorded by ZIC and pickups. Syslog, of course, is going to collect data from several sources. Okay, so this is what SNOT looks like. Consists of two sections as shown in the figure below. The rule header and the rule option. Rule location is sometimes added by SQL. So you have IP alert any any. This is the message. So you this is kind of the configuration message that's been done. So GPL attack response ID check return root. So this is the content. Fast pattern only, the class, then of course the SID. So what this is what the explanation for each of them means. So please check up your Cisco elements. Study. If you have any questions, please don't forget to ask them on the group. Okay, same thing here. Same thing here. They all have their components and the explanation. Now, start our firewall rules. There's actually a lab on how you can capture a malicious file over a network management network monitoring tool. So we'll do them in one of the labs. So all of the places where you have labs, note that there are about more than 20 something labs within this course. So after the 28 modules, we'll go over the labs and they're going to be showcased practically. Okay, need for alert evaluation. So it makes sense that when you implement security controls, that you don't just implement them and you go to bed. You want to make sure that you have alert system. Alerts are very critical to you securing your IT infrastructure. Uh, it's a one security analyst will walk through queues of alerts in a tool like SQL, pivoting to tools like Zik, Wireshark, and Kibana to verify that an alert represents an actual exploit. So the question is that you don't want to miss anything, right? You want to make sure that for whatever alerts you get, you want to evaluate them from time to time. It is better to have alerts that are sometimes generated by innocent traffic and it is to have rules that miss malicious traffic. That's why you want to evaluate your configuration from time to time to see, of course, what is not capturing, what's capturing, and how to improve that detection. So this is a logic class I take for my students, computer science students regularly. So you have true positive, false positive, true negative, false negative. So they all have the explanation, true positive, so the alert has been referred to be actually to be an actual incident. So you really want to have true positive and false negative, right? An undetected incident has occurred. Okay, no. True positive and oh, let me get this. Just a moment.
Uh, True positive alert has been verified to be an actual security incident. So you want this to happen. You don't want to shout uh, fire when there's no fire. So there's actually an event, there's an incident for concern. So and just comes out positive. False positive, the alert does not indicate an actual security incident. Binning activity that results in a false positive is sometimes referred to as a binning trigger. This is a false alarm, right? Uh, True negative, no security incidents occurred, the activity is binning. So this is also what you want. You got on that, right? So you want this true positive and true negative. You don't want a false positive or a false negative. So here it's true. We have an incident, it tells us so. True, we don't have an incident, it tells us so. So any other thing, imagine you have false, you don't have an incident, it tells you you have an incident. You have an incident, but doesn't detect for you. So this is very, very basic and logic. If we check out a logic for true and, so this is and, true and true, false and true, true and false, false and true. So you want to make sure that it's true and it's showing out true. It's, it's true that it's false and it's showing out false. Every other thing is going to be a false alarm. Okay. So this is just an explanation. So like I said earlier on, true positives are what you desire. True negatives are also desirable. So you don't want this, you don't want this. So it can be dangerous. Imagine your tool is telling you that there's no attack, and here your tool is telling you that there's an attack, whereas there's none. So you just reconcile both. But what you really want is these two guys here, right? You want true positive and of course true negative. Okay, determining analysis and probabilistic analysis. So the tool is going to do this for you, whether you're trying to do a deterministic analysis or you're doing a likelihood, that's a probabilistic type of analysis. Okay, that will be all. So let me see if I can explain this a little bit for you, a little bit more for you, and do some case study. For an exploit to be successful, all parallel tests in the exploit must also be successful. The cybersecurity analyst knows the step for a successful exploit. So statistical techniques are used to determine the probability that a successful exploit will occur based on likelihood that each step in the exploit will succeed. So you really want to explore both of them and see, because in as much as you want to be very sure of what you're doing, you want to still check out for probability that a particular certain kind of event or vulnerability is going to be exploited. They want to see how to patch out for it. Okay, that's going to be all for the Cisco Modules 26 evaluating alerts.